Hello, everybody. Welcome to yet another live stream that's being brought to you by the Open SSF, that is the Open Source Security Foundation. I'm your host. My name is Ram. I work on behalf of the Open SSF in the India Geo. And as always, we have an amazing stream waiting for us. Thank you all for joining. I guess our guest is very popular without being on the stream because I see tons more of people than I usually do. So I'm very happy that it's reaching a lot of people, that we're able to make inroads, and that our guests bring their A game time and again. So I'm very happy to welcome Rohit Sadgune on our live stream. Rohit is going to talk to us about threat hunting. Um, in today's climate of all sorts of geopolitical threats and things like that, I think cybersecurity threats should not be left behind. And I think the timing of this stream is great because Rohit brings tons and tons of experience to the table. And I was chatting with him yesterday about what is he going to show, how is he going to do it. And he's got so many stories to tell and so many ways in which to tell it, and just so much information that even this 90-second introduction feels like I'm taking away some valuable time. So without further ado, let me bring Rohit on. Hello, Rohit. Good afternoon. Welcome to our
Yeah,
stream.
hi Ram. Good
So much for
afternoon.
doing this.
Can you hear me, Ram?
Yeah, it's such a pleasure to have
Yep.
you. Thank you so much for being here.
Thank you. Thank you so much for inviting me. It was pleasure to have a word with you before we start. And uh, trade hunting is right now the buzzword of the market. So I thought of
It is.
let's have one-on-one chat with the people who are actually making their hands dirty with the open source technology. So thought of it was pleasure to meet you, and thanks for inviting me on this podcast.
Exactly. So, but then when we were talking, it was much more peaceful times, to be honest. So when we started talking, this is not something we planned, obviously, but I think it's a very critical topic for two reasons. A, based on what you showed me yesterday, there was very little I knew about it, considering that I spent, I don't know, 15, 20 years of doing computer things. Um, a lot of things were new to me. I'm not saying like I'm a security whiz or something like that, but having been in this space, I guess there are certain things that I should have been aware of, but I wasn't, obviously. So I'm really looking forward to a lot of learning today, as I'm sure many of our guests are.
Yeah,
And
definitely.
yeah, considering all of that, why don't we kick things off by introducing you? Just give us like a quick introduction of who you are, what you do. But also before that, if folks have questions, there's like chat links uh, on the channel. So if you have any questions you want to ask Rohit during the stream, anything you want us to pause on and emphasize on, or have questions answered, just drop it in the YouTube chat. I'll pick it up from there, bring it on camera, and then we can answer them and go forward. But Rohit, please introduce yourself before we go any further.
Sure. Thanks for this warm welcome. So, hello everyone. This is Rohit Deepak Sadgune. I'm basically from Pune. I was born and brought up in Maharashtra, and since last 10, 15 years, I'm in Namma, Bangalore. Uh, and I have total 15 plus years of experience purely into threat hunting. I'm doing threat hunting when there was no word called threat hunting. We used to do analysis. So way long back in 2010 or before that, I used to go carry firewalls and implement firewalls and identify the patterns after implementing the firewall, that how the traffic is flowing and everything, do the log analysis, do the packet analysis, intersection of packets, and then find the problems. So from there, I started my journey. I'm working as an senior cyber defense manager, company called Savient. Here I take both part of it. One is the enterprise security, second is the cloud security. I'm primarily focusing on threat hunting and intelligence part, where my job is to find the sophisticated threats for my enterprise. So this is about me. About my in parallel things, I write blogs. So my blog is hackforlab.com. So if anybody wants to uh, learn the new way of threat hunting or what are the new threat actors, malware campaigns which are active right now, they can actually look into my blogs. They can subscribe as well. Over there, I used to publish every week what are the new threat actors, campaigns, and malware. So this is about me. Nice.
Rohit, if you don't mind me asking, do you have a very dangerous job?
Sorry,
Do you have a very dangerous job?
dangerous?
Is the work you do very dangerous? You make it sound
No, 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 no,
like
no, no.
risky. Right?
It is not. It is the day-to-day work. See, uh, after completing my presentation and a few labs I've already created for the viewers, they will understand why you need threat hunting and what is the job is all about. It is something that very deep understanding of your cybersecurity posture. If you know the deep understanding of cybersecurity posture, you can be a good threat hunter. And this job is right now getting a lot of traction in the market. A lot of enterprise banks and BFS sector, every other sector, they are now looking for the red hunters because traditional solutions are not enough to detect the sophisticated attacks. So this is the upcoming field. I will say this field will be there for long because you cannot do that level of automation because it is the brain who is working behind that particular attack detection. So it's a general stream. It's not something dangerous, something like that.
Got it, got it. You mentioned that you had some slides and things like that. I'm going to bring those up, take us through your talk. I also know that you have like a demo and things planned. Like I said, every minute I do some kind of chit chat, I feel that I'm taking away something very valuable for our audience. So I'll let you at it and mute myself. Go for it, Rohit.
Yeah.
Your
So,
presentation is now
so
visible. Take it forward.
sorry. Yeah, present. I've shared my presentation. I hope everybody can see the presentation.
Yeah, your presentation is now visible. You can go ahead.
Okay. Thanks, Ram. So I will take this further. So we have a jam-packed agenda today. So what we are going to cover is threat hunting. So basic definition of threat hunting. Then we'll talk about the different aspects of threat hunting. Then we'll take the life cycle of threat hunting. What are the primary pillars, four pillars of threat hunting, without which you cannot do any sort of hunt in the market, without which you cannot do any cyber security related stuff uh, as far as the enterprise security is concerned. Then we'll talk about the business case, why you need threat hunting. Okay, then I will give you a live scenario where there was a real attack and uh, how that attack actually progresses and why there are gaps in the existing detection solution where the threat hunter comes into picture. Then we'll talk about open source. We'll take our journey to the open source tools and techniques which are there. I will cover a few of the tools. I will show some demo in my lab. I have built my own lab by spending thousands of dollars. So I built my own lab where I will take everybody to my lab and we'll do some basic uh, hunting. Then I will talk about the methods of threat hunting. That is very important. Types and methods of threat hunting. Then I will show the architecture diagram. I built that entire architecture diagram using only open source solution. You don't need any commercial solution available in the market to build a threat hunting lab or threat hunting practice. Then we'll definitely talk about the labs, and I will show in after labs I will show few attack flows that I built. Then apart from that, I will show the diagram or you can say architecture layout of how you can build your own practice of TI, TH, and D. TI stands for threat intelligence, TH stands for threat hunting, and D stands for detection engineering. So this is the overall agenda that we have. So I will start with what is the basic threat hunting. So threat hunting is a proactive measure. It is not at all reactive. Okay. Threat hunting starts with the activity data. It is not, it never starts with the alert data. Now, in your enterprise, you are using a lot of detection platforms. You have SIM, your CSPM, your India, lot of detection platforms that you have. So they are generating a lot of alerts. To manage that alert or to respond that alert, there is a separate team called SOC. The threat hunting team will primarily focus on the things which is not there in your which is not there in your detection platform. So they will assume there is a proactive measure that they will take. Example, they will assume that okay, in my company there is a PowerShell someone is using. Okay, is it legit or not? Let's say the marketing team is using PowerShell. Is it legit? No. If it is not legit, then how I can track that? And if it is not legit and still the I can see the PowerShell commands that are getting executed on that machine, then definitely there is an adversarial effect that I can measure over there. So this is the risk that I'm calculating right now. So this is the hypothesis that I will build. Okay, let's say I want to identify scanning. So a lot of scanners are there in the market who are scanning right now, but which scanner is actually scanning on me, which is going to create an impact in long run, that okay, these are the indicators, these indicators belongs to this particular threat actor. So I will take that particular thing and I will do a proactive measure. So I will continuously look into the logs, packets, processes, and your identity related data, and then I will build the hypothesis. Once that hypothesis is built, you will have two things which will come into the picture: the functional aspects, and when you actually drive the benefits and the key objective. So the benefits of threat hunting is basically it actually a time series correlation that the threat hunter do. One slide after this, okay, you will see why you need a time series correlation. That adversary, when it is called ATS in the market, adversary trajectory system. So when adversary is in your environment, how it actually moves from A to B. So a lot of solution will focus on the MITRE attack flow, where it will start from left to right. If the adversary is able to move from left to right, it is something which is you will have a devastating experience. But it is not the case at all. I will show one diagram where you will find that the adversary has not ended their entire journey on extreme right of the MITRE. Okay, it has ended somewhere in the middle. So this is the benefits is something which is time series correlation. That is very, very important. And the key objective is that you will continuously perform the analysis and you will give that information back to the detection engineering team or back to the infrastructure team. That is the key objective of threat hunting team. That example, I was able to detect one of the VPC, okay, from where one of the machine from where there is a communication was going out. Now this is where I have to involve the cloud ops team that go ahead and block this particular traffic, because I don't hold that infrastructure. Because if I'm a checker, I should not be a maker of that. So there is a maker and checker procedure. So maker will I will inform that maker boss, go ahead and block that particular traffic. So these are the primary objective of threat hunting. So the benefits and objectives of the threat hunting. But if you go ahead and define the entire flow, or you can say the life cycle of threat hunting is like this: you cannot protect anything till the time you cannot see it. Okay, if you don't know where is my infrastructure, what are the instances, what are my admin accounts, what are my where are my firewalls, how many firewalls I have, how many vendors I am holding right now for that particular firewall, you won't be able to give any justice to the enterprise security. Or even in the cloud is something which is a really myth, because in cloud, finding the asset, there are a lot of solution in the market, but they give the information about what are the assets and accounts that you have, but how they are correlated, there is a very big gap. So visibility and data collection is the first step of threat hunting. Then the getting that information and then correlating that information to the threat intelligence and TTP is what you have. That is another thing. Okay, this is very, very important. Now once you are able to correlate that, you will receive it. Okay, this is something which I know. Okay, this is, you can say, it is a low hanging fruit. Now after that, you will take that to analytics and automation level, where you will run the different set of algorithms. Example, if I want to run the Cummins algorithm, or if I want to run maiden algorithm, or you can say cohesive cluster analysis, lot of things that you can do. This is the actual analytics. And all these three things, okay, is possible because of you, because you need to have a good brain. So people, process, and technology. Out of that, people and technology is the primary thing that I'm targeting in this skilled analytics platform. So the man who is identifying the threat actor, he will go behind that threat, okay, or go behind that malware, he will go behind that particular initial indication from the any of the stream packet processor logs, and then he will take that into a technology, that okay, now if I want to do this scalable thing, I need to get into the technology. So he will write a script, or he will take this to any detection platform, he will get it to the big data lake or anything. Okay, this is the hypothesis. He was able to reach to somewhere. Now he want to identify what is the propagation, or x-axis and y-axis. Okay, so this is where you need to have a skilled person, a technologist, as well as a good technology. Okay, now you can use open source as well. There are a lot of good open source technologies are available in the market. One can use, and they are highly effective. I've seen many cases where the open source technology was able to detect more complex threat than the commercial solutions. This is what is my experience, and I'm using open source in my lab as well. I will give the walkthrough as well for that. And then now this is where you are going to take this feedback and continuous improvement. Now you have learned something that, okay, if I want to detect, let's say, beacon attack, okay, there is a randomized beacon. Now I cannot detect this using the current method what I have, a, and current technology I have. Now you will take this to detection engineering, where you will work with the engineering team. They will write a code for you, or they will build a solution where you have aggregated the data. Now that data, the actual threat hunter will give the input that, okay, I want to identify randomized beacon with this particular pattern. So this is the pattern that you will give to your engineering team, and that engineering team will be the different set of detection platform for you. So continuous feedback is also important. Now this is the cycle of threat hunting. Now if you go ahead with the pillars, so there are four pillars of threat hunting. So logs, packets, process, and identity. Without this you cannot do a threat hunting. If you want to be a good threat hunter, you have to be a master of this thing. For example, I'm doing authentication, let's say Rohit, and I'm authenticating Rohit is my password, and let's say I'm using LDAP server. This is the best case scenario. When I'm authenticating, I'm using R112 as an account. Okay, that is my identity. Okay, Rohit is a user, and it is associated right now with the R112 as an identity. Now, this identity, when it performs a transaction, it uses lsas.exe. Okay. Now, when he authenticate to AD, it is something that I'm authenticating on the behalf of someone. There you will find two things. One is the 4624 transaction, which is the log. And then when I'm interacting to domain, it is the something 389. That is my LDAP port. Or if it is a LDAP, it is a 636. So now, if you cover this, these are the four pillars of threat hunting. If I want to identify anomalous transaction from this, I need to understand what is 4624, that is my log. What is the port on which it is interacting, whether it's a TCP, UDP, whether it's secured or not secured, something like that. So it is the packets through which I can identify that. I will write TCP.flag equals to 1, and I will write the port equals to 389. So this is the thing that I will filter it out. Then identity. Who is performing the transaction? That is R112 is the account who is performing that particular transaction. And the process is the LSAS. So the four pillars of threat hunting. Now, if you take any log source, any technology, anything of the market, you can actually categorize that into this four. And you can go more deep, and more you go deep, you will find a lot of limitation over there, and that limitation is something that is the point of threat hunting, because that is the limitation of that particular solution, where threat hunter will come into picture and they will do the manual or automated way to perform or detect that particular adversary. Now I will take you to this case of actual scenario. This I've taken it from one of the source. Now left to right, if you see, attacker has sent a phishing email. Now that phishing email, when you receive an email, first thing is the log sources phishing. Now you will have any email gateway that will come into picture. Now, if you see second thing, legitimate web phishing page URL. Now, when you actually click on that phishing page or the URL, two things will happen. Okay, if it is there is a process over there, the process will be generated on your machine. So there is an event that is related to process is 4688. Okay, or if it is directly redirecting from your browser, in your proxy logs you will see 307, because it is redirecting. So event outcome will be 307. I'm getting very technical, but this is a real technical scenario that we are talking about. Now, adverse in the middle, AITM phishing page will come into picture. Then credential compromise will be done. Now that credential will be used. Okay, again back by the attacker. Now here I'm taking it mouse. So here you will see that attacker has now have the credential. Now he is authenticating. Now when you authenticate, email inbox and all he is going to do, his business email compromise BEC campaign will be run. Now he will move laterally. Okay, now he will use all the internal users and second storage, BC campaign from the compromised asset. So over here, if you see email gateway, proxy, user, traffic, processes, there are tons of silos are there, and these silos don't talk to each other. Okay, there will be a lot of solution. They claim that they are talking to each other, but it is very difficult to teach them now. They are not talking to each other. If I'm talking in Marathi and you are talking in XYZ language, it doesn't make sense. You need to have something in middle. Okay, or I need to learn your language or you need to learn my language. Okay, so there will be something that you have to stitch this together with a proper common entity or identity. Okay, that will not happen. When you talk about packets, it is all about the IP addresses, or you will not get the or host information maximum that you will get. You will not be able to see the what is the user that is authenticating. It is something that it will be there, but correlating that back to the entity will be another challenge. So this is the problem. This is the really big problem, and this problem is identified by all the threat actors. That all the detection platform in the market, they are claiming lot of things, but it is not something which they will be able to detect us. Okay, so that problem statement was identified by all the threat actors, malwares, ransomwares, and all their different types of adversary, and now they are leveraging this particular thing. Now if you consolidate this thing, okay, you will have different set of detections that will be coming in. Email gateway will have 10-15 detection, machine will have 10-15 detections, or one or two detection. Your proxy will have one or two detection, and then MFA comes to MFA logs will be there. So MFA logs will say that okay, authentication done without MFA, and lot of things will come into picture. But these silos are not talking to each other. What is happening over here is this is the best case scenario that is happening right now. If you see here, there are 13 arrows that you are seeing right now. They are actually the archery man is just hitting, he's sending a lot of arrows to the target. But if you see, only one particular arrow was able to hit. Now, out of this multiple 13 alerts that we are talking about, only one alert was able to give you the information. Now, stitching this alert back to this 12 rest of the signals, it is a really big task for any detection team or a SOC team. So, what is the problem that is there? They reliance on the known threats. Everybody is relying on the known threats. That okay, what is lateral movement? What is uh, example scanning or indicator? Do you have any IP communicating to C2 server, or do you have is there C2 server interacting to me, or is there a malware IP scanning on me? Basic information, that is the known which you have. Okay, I'm talking about completely unknown. For example, caterpillar lateral movement, or spider lateral movement, or example, the case what I will show, the black Basta, or UNC38, or APT. So these are completely unknown. They use the different techniques, or rats, remote access trojans. So they don't talk to each other, and that is the reason they are completely unknown. Okay, and what is the threat hunter is doing is very good example I will give you. You have a fever. So you have a fever. What is happening in the market? For every fever, there is a drug which is available. For example, someone will give, let's say, a paracetamol drug for you. Okay, paracetamol. But for every fever, it is not the solution. Okay, so they will ask you to do a test. Okay, so after testing, you will know that okay, you have a corona fever, you have typhoid fever, you have malaria fever. That identifying a specific type of fever will be done by your threat hunting team. That okay, what is that adversary, who is that adversary, what is the motive of that adversary, and where he want to reach in my entire enterprise. So that is the main task of threat hunting team. I will now take you to the journey of open source tools. So there are lot of open source tools available in market, but before that we have to understand what is the importance of open source tool. So I'm using open source tool since 2008 9. So at the time there was, I'm not sure whether ELK was there or not, but I used to aggregate all the data in SQL. I'm still doing that. So open source tool is it is the next level of beauty. A, you, the way you want to customize, you can customize. If you are going to go for a commercial solution, what happens is that they will ask you to put your solution into a particular cloud environment, or let's say on-prem, you have to bear a lot of cost. Second thing is that if I'm moving from a vendor to another vendor, it is packing that circus is another big problem. Okay. And when you pack that circus, most of your players will go away. Okay, because uh, you have to put a lot of effort to build that entire circus, and then when you are taking that entire circus down, so many of the people will think that okay, now the circus is getting down, now another effort I have to put. So that is another problem that they have with the commercial solution. With the open source solution, you can build your own set of scripts, you can build your own set of configuration files, and you can deploy it on n number of tenants. So that is the beauty of open source. I'm using OS query, I'm using a lot of Linux commands, I'm using open source database, I'm using open source log aggregator, where I'm actually putting a lot of data. So this is the beauty of open source. Now there are a lot of solution in market which will help you to build your own threat hunting lab. When I will show the entire architecture of threat hunting lab, everybody will understand that they can build the lab by themselves. Okay, it is not a something you can say it's a rocket science. It's just a intent. You know, to have attitude and intent to create a lab. And once you will be able to build your own lab, you can practice, and more you practice, more you are getting close to the threat actors to detect it. Now, if you see here, I'm talking about log aggregation. So in the log aggregation, you have ELK. You can use. I'm using. Everybody will just shock. I'm just aggregating the data because I have very less number of data. I'm just aggregating 1,000, 10,000, 15,000 files which are available in GitHub and everything. Where I'm doing analysis. Okay, what is the actual threat that was done, or I'm getting it from the open source and I'm putting it into database. Now I'm writing the complex queries. So you can use any open source database as well, or you can aggregate that into ELK. Endpoint OS query. I'm using OS query since 2018 or 19. It is the best open source EDR platform that you can have, and you can customize it. There are a lot of companies that are there in market who are using open source. There are a lot of banks as well. In my past experience, I'm telling you, there are a lot of US bank they're using OS query, and there are a lot of company who have built the commercial platform on top of layer of OS query. So this is another thing that you can use. Zeek, Wireshark, T-Shark. So I will tell you that Wireshark and T-Shark. My experience, Wireshark is where it is the best solution. I think it is the biggest open source uh, mm, platform, you can say, a contributed platform, if I'm not wrong, of the market as far as cybersecurity is concerned. Wireshark, let's say I'm going to aggregate or I want to search for 10, 20 GB of file, it is very difficult. But T-Shark is something that you can do. I've written a lot of blogs on T-Shark as well. You can write the simple commands T-Shark -r and the file name. You can start analyzing the protocol, traffic. Now over there, you will combine with the T-Shark commands with the Linux native commands like grep, sed, awk, and everything. Now you can find the sophisticated thread. You don't need commercial solution to do group by having count of testing. It is something you can do with the Linux commands as well. I will show some examples in my lab that detecting these threats, it just you need to have a brain and just one system with the Linux, and that is enough for you to be a good threat hunter. Now, Mosef, it is a Mozilla defense platform. It is a SIM. It is open source SIM. Elk is also open source. Sigma rule. So there are a lot of uh, practitioners now following Sigma rules and Yara rules. You will have a bunch of repositories available in GitHub. Okay, let's say I want to identify user created and deleted in small period of time. I can have this Sigma rule available in GitHub any for sure. Okay, so open source, there are a lot of contributors for this. The biggest advantage what I missed in the left side part is open source will have a lot of contributors. With the commercial solution, you will have only limited set of computers. Uh, uh, Aggregators as well, because open source, where let's say I am the one who is finding something, I will give back to the open source community, boss, this I've detected, can you please add this, and now this will be added, and now this feature will be available across hundreds of and thousands of users which is there in market. But with the commercial, with the contributor, if you talk about, they have limited set of contributors because they have to they have to pay. Okay, they are on the roll. Okay, so they have to pay. I don't know how many commercial solution are available in open, and they are getting this information back and adding into as a learning from the contributors of the market. So this is the another limitation of commercial solution. With the open source, this is there is no limitation for this. Now, technical capability is very important for us to understand. The With the open source, you can actually script anything. For example, I was planning to I have a lab, I have this 3 4 laptops. So I thought of I will create an UI where I will just aggregate all the OS query related outputs. So I've created a query. I've just shifted that query on machine, and I was aggregating the data. That query I've added for just run that query for, let's say, every 3 hours, and I want that output to be shared to back to by one of the dashboard. I was able to do that. I don't need any commercial solution for this. Okay, so that scripting and you can say flexibility you have with the open source solution as compared to commercial platforms. And another thing is behavioral detection. All the behavioral detection. For example, if I want to identify, let's say, low and slow traffic. Now I want to write a detection where I want to identify from A machine to a B machine with the same set of port and same set of bytes transaction that is happening, and I want to create a script, or I want to identify what sort of behavior that is generating over there. Okay, so that detection is really possible. I can customize this. Now let's say tomorrow I want to identify that incremental behavior, that with the with the logs what I have, I want to identify that how many times that increment of bytes is happening. Okay, for example, first transaction was 2048, then it is 3048, or then 3522. So from A to B, how many shifts are that are happening, and what is the behavior that is generating for me. So that if you want to write this in commercial solution, it is very difficult. But now if you have any open source platform available, you can actually write a script and you can detect this sort of behavior. And now this what I was talking about is called as a random beacon. I will talk about this in the few slides, but this particular information is very very important, that with the open source you can build this. And I've built, basically I will show some command where we'll talk about how you can detect a beacon using simple Linux commands as well. Now uh, types of threat hunting. So there are only two types of threat hunting. Only two types: active and passive. Okay, active is something which is real time. You have logs, packets, processes are coming in, and this is the active real time data analysis what you're doing. Passive is something that now let's say assume that let's say there is a threat actor who actually compromised your enterprise environment, or who was able to compromise any company. Now you will aggregate that packet, process, and logs and identity related information. Now do you will do the passive threat analysis, that okay, this has happened, how that has happened. Okay, active threat hunting is really really helpful to do a proactive measures, that okay, I will assume that okay, let's say there is a caterpillar lateral movement I'm identifying. What is a caterpillar lateral movement? So there are only two types of lateral movement. One is caterpillar, spiral. Caterpillar, that means caterpillar like this. So what happens is that A to B, A to C, A to D. So this is the way actual caterpillar will go. Spiral, that means A to B, B to C, C to D, D to E. Now when actually adversary was able to do this, you are far away from the actual threat actor. Okay, spider lateral movement is very difficult because there is no point of correlation right now. Okay, but with the passive threat hunting you can do, because now you have liberty to take identity or take machine, take it to another level, then again identify the next level or next stop, then take it to another level, correlate that with the patterns or user level information and everything. But it's a time consuming process. With the caterpillar lateral movement, it is bit easy. I'm not saying it is that easy, but it is much easier compared to the spider lateral movement, because it is you have right now in control of the situation. Okay, in control of that log. But moment it becomes to a spiral, you are far away from the control. A to B and B to C. So correlating this B to C and C to D is another problem. Now, how you will say that the threat actor who was performed the transaction from A to B is the same one who is actually moving from A to D? It is the challenge. So this is something that you can do with active and passive threat hunting. So active hunting is the real time threat hunting, and passive hunting is something that you have the data, and now you're doing the deep level of analysis on top of it. Now, uh, as we have learned about the types of threat hunting, so after type, we will talk about what are the methods of threat hunting. So methods of threat hunting is we'll talk about few methods. There are a lot of people will talk about different types of method, but based on my experience of 15 years, what I've already burned my hands. I fall front. I've made my hands dirty on a different set of logs. From that, I'm giving this learning to you. If you think about methods of threat hunting, these are the methods. One is hypothesis driven, intelligence driven, behavior analytics, situational ad hoc, and the automation scripted. Hypothesis driven is that I will build the hypothesis that okay, I want to identify someone is using PowerShell. I want to identify. I will assume that in my enterprise there is XYZ threat actor. Now, if that XYZ threat actor is there in my enterprise, what are the technique, tactics, and procedure associated with that threat actor? Let's say I have now 10 technique, tactics, and procedure. I have now 10 techniques. Now I will try to validate the 10 techniques in my enterprise by searching across my data lake that whether there is a real trace of this particular adversary. Now I may get hit for first out of 10. I will get hit for second, third, sixth, and eighth. But I will not get hit for four and fifth right now. So this is the gap that you will see. Now there are two things with this particular gap. One, the gap is because of you don't have telemetry. Okay. So what is the telemetry? Where you will now work very hand in hand with the IT infrastructure team. Hypothesis driven hunting will actually help you to get enterprise posture to a really good level. In in Windows log, if you talk about 4688 is the event ID where you will find the source process and destination process. But many companies, they are not enabling the command line that if I'm going to use netstack, okay, or I'm going to use ping, so what, or I'm going to use A on the behalf of B. So multiple commands that I'm using, so that command will get actually logged. Okay, what is the command that was executed by on that behalf of that particular event, that 4688 event ID? It's a command line, simple attribute. Many companies are not enabling that. So that deep level of understanding you will have when you will do this analysis that okay, four and fifths I don't have because that enterprise is not logging that particular telemetry. So this is the hypothesis driven. Now coming to the intelligence driven is not only based on the IOC, it is also based on the TTP. Or in, intelligence is also talk about the processes, commands, file names, ports. I will give you a walkthrough on example. I want to identify how many. I built one particular platform where I've added a lot of ports. I will just write how many ports right now used by malware where port is 5555. Okay. Or 4444, 2222. Metasploit uses 2222. But I want to identify how many rats, remote access Trojan, are active with the port right now. So this is the intelligence that you will build. Okay. This is the learning that you have from the past, your experiences. And now you will actually consolidate that into open source platform. Now you will write just simple query and you will get all the answers for you. Now, behavior analytics is something where you will what I already mentioned last is that you will now build scripts of models that I want to uh, identify a user who is performing abnormally higher number of login failure. This is very simple scenario. But if I want to identify, let's say, a user who is sending data to his personal email ID, this is a good example of behavior. So what is his behavior? Okay, what is the rare transaction that he's doing? Okay, and can I use fuzzy logic in between to identify Rohit Sadgune? Now he's sending that r sadgune at the rate gmail.com, whether he is sending something like this to. So now here you will now do the permutation and combination and combining different fields of Rohit user attribute, and you will say that okay, this is I'm saying that 80-90% close, that this is something that you are saying that it is sending the data. Now situational is something which is right now everybody is doing right now, because lot of CVs are coming in, lot of threat actors are now exploiting new set of vulnerabilities. And this is the situational or ad hoc hunting. For example, CV recent nginx reverse vulnerability, where there was a CV associated with that. Now everybody was doing hunting that whether my infrastructure is vulnerable to this. If it is vulnerable, how much is the deep impact right now? So that is the situational hunting. And ad hoc and scripted hunting, Now once you have learned everything, okay, now you will give that information to the engineering team. Now they will, in the hunting itself, you will have a engineering team where they will automate this. Okay, you have to write a script. Example, I want to understand, I want to identify a machine which are HVA for me. What is HVA? High value assets. Now you have all the logs. Now they will write a script for you, and now you will do automation threat hunting. That okay, take that HVA, high value asset list from my IT infrastructure team. Now you will code it, and over there you will write your algorithm. Now you have only crisp set of information which is saying that okay, these are the two machine which are compromised, which are under high value assets. Now here what you're doing, you're taking into a funnel approach. Moment you get into a funnel approach, the chances of reducing the false positives on higher side, as well as the residue what you are going to get, it is something which is actionable. So that is the overall methods of threat hunting. Now, where I'm taking everybody is the real thing called as a threat hunting architecture. Okay, I've built this. I'm not sure how many of there in market who have built this, but I'm the one who actually built the entire threat hunting architecture using open source platform. There is no commercial tool over here. Now, if you see, you have to start from down. Okay, start from the left side, endpoint solution. Okay, process. So I will just mark it. I don't know whether I will be able to mark it. Okay. Now, if you see here, these are the endpoint solution that you have: EDR, Sysmon, and events and everything. Okay. Then logs, these are the logs. Any transaction that is happening, let's say I'm authenticating, or let's say infrastructure log, application log, cloud logs, cloud, all trail logs. Okay, all trail logs. Okay, then packets, your India solution, your bro, or all things, now you are putting that into a data lake. Now that data lake is now actually where you see the blue box over there. You will have different methods of hunting. Now to do that hunting, you have left side and upper side. So left side you have HVA. You will start with aggregation, contextualization, normalization, asset, entity, HVA, HPA, high value asset, high privileged accounts, relations, groups, peers, and functions and everything. Now you will take that into the how you can do this. To do that, you have upper layer. You will use all the different set of commands: grep, set, odd, unique, tcpdum, os query, or velociraptor, ADR solution, and everything. Now what is the output of that? With the architecture, you will find what is the output of that. Now with the output, you are going to get the MITRE attack flow that you can build. Okay, detection engine that you can do, MITRE attack coverage that you can enable, real-time intelligence that you can add, rate teaming scenario that you can build. So this is the overall architecture that you can build. Okay, I built this based on my experience and my knowledge. There are a lot of things that you can do it by yourself as well. Now I will take to a journey, and then we'll go into the lab. Now we'll talk about few attacks. One is the NBAD, network behavior anomaly detection. So starting from left, if you see low and slow traffic, okay, or DDoS, or randomization, constant beacon, periodic beacon. So what is a random beacon? It's a very complex attack to detect. Really, really complex attack. I will send 10 packets, okay, to command and control server. Now with the 10 packets, after that I will wait. So 10 packets, one 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 one. Okay, after that I will wait for 5 seconds. This is called the sleep period time. Now after that I will send 5 packets. So this is another random number. Now for that 5 packets, I will send 5 packets, and then I will again wait with the random number. Okay, 7 seconds or random number that I can decide. So there are, based on the experience what I had, there are almost 84 types of beacon patterns are there in the market. A lot of different patterns that you can build and establish. Okay, I was able to identify almost 16, 18 patterns within my lab itself. So there are different types of beacon pattern that you will have. This is called random beacon. Now second thing is called as a constant beacon. Now with the constant beacon, what you will have the same period. Now if you see the left side diagram, time interval 1, 2, 3, 4, 5, and number of packets, similar number of packets that will happen. This is the constant beacon. Now periodic beacon that will have, I will send 10 packets now. After 1 hour, second packet, and then third hour I will send another 10 packets. So that is a periodic beacon. Or I will send today 10 packets, tomorrow 10 packets, after tomorrow 10 packets. So it is really difficult for your perimeter defenses to identify whether real exfiltration is happening or not. Now this is the overall thing. Now I want to take you to the journey of lab. So I will open my lab. I hope everybody can see my lab. Ram, you can see my lab. Is it visible?
Hi,
Sharp.
Yeah. Can you make the font a little bigger?
Yeah, okay. Is it okay?
That's better. That's good. Yeah.
Yeah. So this is the lab. So just take, I will just write simple commands I've already written in the interest of the time because I know Ram is going to buzz me, Rohit, we are running out of time. So that is the reason I've already created a lot of commands to show. For example, now I'll just take this traffic data. So just analyze this header. Okay. So what this header is talking all about, that this particular file has these columns: version, account ID, interface, source, destination, source port, destination port, protocol, packets, byte send, start and end, action and log status. Okay. Now let's start with something which is very basic, very, very basic. Now, I want to understand to detect port scanning. Okay. I want to understand, is there anyone who is doing right now horizontal port scanning? Okay. Right now, just paste this command. Okay. Now, what this command is giving back to you is, if you see cat, I'm just printing the numbers. I'm just analyzing that number. Horizontal port scan is something that how many ports that was scanned by particular IP. Okay. Now, if you see here, these are the 101.35.28.105. This is the IP. He has scanned 11 ports right now. So this is the horizontal port scanning. Now, if I want to identify what is the vertical, is there any vertical scanning? That means one particular target, many ports. Okay. Same target. I will have only one target with the multiple ports that I'm scanning right now. So with this, you can actually search. Now you will have that, okay, this is the IP who is now doing vertical scanning, horizontal and vertical scanning. Now here, the simple command I've written, uh, it is the it is the actual hunter's thing or hunter's expertise where he want to do group by and where he wants the unique values to come out. So that is the thing that I've written. Now all these commands I'm putting on my own blog as well so that everybody can use this. Now let's take one scenario. Fine. Okay. Let's take this another scenario. I want to identify from my entire EC2, that is the VPC flow traffic, what I have, these logs. I want to identify, is there external communication that is getting established? Yes, that is getting established. Okay. Now, if I want to understand, is there a DNS tunnel? So DNS port is port 53. Now, if I want to identify, is there a DNS tunnel that is getting established, or is there a number of packets that are getting exfiltrated from my machine? Now, if you see here, I'm just writing awk 53. Okay, that is look for my 53 port from the seventh column of my file. Then print fourth and fifth column. That is my source and destination. We saw that header. From that header, fourth and fifth column was my source and destination, and then sort unique. And then I'm saying that if the count of $1 what I've identified is greater than 50, then give me that information. Okay. Do I have? No, I'm really good right now in shape. Now, same similar thing I can do with the RDP as well. Similar case, just I'm just changing the port and I can actually identify, is there a RDP tunnel? What we discussed just before that, there was a RDP tunnel, SMP tunnel, SMP tunnel. You can also detect that. Oh wow, nothing is there. Now, can we identify pair transaction that are happening, that number of, or you can say beacon. Now let's take one beacon scenario. I will just paste it here. Now, what here we are doing, same source, destination, communicating to each other with the fixed interval time. Okay. Now, if you see here, I will do pipe more. Okay. Now, if you see here, this is the source communicating to this particular, that is 193, 127, communicating to 10.005. Now, if you see incremental timing, you can see 171.14, 117.1482 is common. After that, everything is getting random. So, he's creating a persistent communication on my enterprise. Okay. This is the best example that you will find that, okay, how many interaction that are happening on my infrastructure from outside with the periodicity. Okay, now I'm not getting into scanning. This is something that he is making fool to my firewall. Okay, now how I can go more on top of this, that high frequency of low bytes out, that we were talking about, low and slow kind of attack. Now if I want to identify low and slow attack, just now this command $10 stands for my bytes. Okay, how many bytes that are getting interacted. Now what I'm printing, I'm giving that information and $12 as well. So that is the number of packets that are getting interacted, and $11 as well. So if you see in my header, we have all the information about what is the column associated with which number. Now I'm printing 4, 5, and 11. Okay, the number of bytes that are getting interacted. High frequency, that is, I'm interacting to my IP is A, X, and another IP is Y. There is a very high interaction that is happening with the low bytes. Okay, this is very difficult to detect by your perimeter defenses, because anything which is less than 400 bytes or 300 bytes, moment it goes down, it is very difficult. Moment it goes up, there are a lot of policies that you will build on your perimeter defenses. Now if you see here, there is a lot of traction that is happening. Now if you take one of the IP, I have already added this IP. I don't know whether you are able to see the okay. Now if you see 185 IP, so this IP is already, you can see this is malicious in nature. Okay, there are a lot of threats are associated with this particular. Oh wow, resolver rat is there, remote access trojan. So this is the scenario that we are targeting right now. Okay, now let's take last command, one slow byte. Uh, mhm. Okay. Now you can see for every command, I'm printing something that everybody will understand. That look for same byte count from multiple IPs. Okay, look for same byte count from multiple IP. Now, if you see 2048 is the count, that 2048 is the byte, and 219, that this IP 185.7.214.3, this IP communicating to .5 IP, which is my infrastructure IP, and he's sending 2048 bytes continuously for 219 times. So this is the pattern that I'm establishing right now. So I don't need a commercial solution. Okay, I'm now reaching to a level where I'm defining the pattern. Now this is the perfect case of finding the potential defensive evade that attacker is doing right now. Okay, so this is the thing that you can do. Now I will take you to another tool, which is well known in market, which is OS query. So if you go to OS query, you just need to type OS query and you will be in. This is the open source EDR platform. Now you can do simple. Let's say I want to identify, it's a SQL based platform. So I want to identify tables. Oh shit, sorry. Now these are the different set of tables that you have. Okay, these are, you can actually build your own as well. For that you need programmatic effort, but this table are enough for you to hunt in the system. Now let's say I want to identify how many users or pseudo users you have in your enterprise. Now I want to identify on one machine, it's okay. But if I have, let's say, thousands of machine, I will just create this command and put that into config file, and it will give me how many pseudo users are there in my entire enterprise. Okay, it's a free. You don't need to bear any cost. Okay, now how many USB devices right now connected in my company right now? I will just create this command. It is going to run across all my 1000 machine, and it is going to give you this sort of output. Now I can take this output, I can put into any relational database, because this is the simple CSV based output that you are getting in. Okay, you don't need a commercial solution to do analytics on this. You can take this and put it into MySQL, and it is enough for you to do that. Then I will just take oh wow, this is something which is very important. There are 10 to 15 MITRE technique associated with this. There's a list share history for each user on the system. Okay, now can you see here? Each shell history, whenever there is an attacker who is doing any transaction, he will actually do evading. That is, he will he will clear his track. Okay. Now, if you take this scenario, just mark the scenario. I will open one diagram, and then we'll go back to presentation. Then I want to identify ports. Okay, this is another scenario in Linux. How you will identify that which process or which binary is actually creating a connection for me outside of my system. So if you see, I was able to find that okay, this network manager is the process, okay, path, name of the process network manager is generating the traffic 10002. Currently, it is on standalone, but moment you get into enterprise, you'll find a lot of process who are generating the traffic. Okay, now take this scenario. There are two things that I will talk about right now. One is whenever we talk about adversary, we talk about MITRE attack scenario from left to right. If any attacker or adversary able to get from left to the extreme right, that means he has completed the journey of an adversary trajectory system. But it is not the case at all. I'm telling this very honestly to everybody who is listening to me. It is not the case at all. This is the case of Black Basta. This is the Black Basta uh, uh, attack flow. Now it starts with something I don't know whether you are able to see. Ram, you can see right now. Ram,
Yeah, it's fine.
yeah. Okay, it's fine. So it starts with phishing. Okay, it is doing. These are the different set of techniques that are getting executed by Blackbuster. Now, finding these techniques and stitching this technique is not at all possible by any detection platform. I'm not sure about it. It is very difficult for anybody to actually correlate these transactions. Okay, now it is using encrypted traffic and everything. But very important thing is that after doing this, he is not actually on the last tactic of that particular platform or on the MITRE side. What he is doing, he is now clearing his track. So it is, if you see here, this is the thing indicator removal host file. So what you are seeing right now, the history command. So what he is actually trying to do now, everybody thinks that attackers who goes from left to right and it is the success. It is not the case. I will show you here. He is under right now defense division. He has completely he has done his journey from left to right, but again he's coming here or there. So the detection platforms which are there in market, they are not able to detect the entire journey of that threat actor because they are thinking from just going from left to right. But attackers are not going in that direction. And attackers are not exactly going in the way what the actual defense solution are thinking. So this is the very big gap. Okay. Now I will take this opportunity to just give a last thing, which is the how you can build your own practice. Okay, if I want to build my own practice of threat intelligence, threat hunting, or detection engineering, you can actually build this. Okay, this is the diagram. So actually start with this particular left side corner. Research team will also suggest to Intel team and build the attack flow from here. So actual threat researcher who are actually taking the binaries, going in the dark web, deep web, and doing research, they are very close to the attackers. They will get all the information. Now that information will be passed to MITRE attack flow. Okay, that will be passed to intelligence team. They will build the attack flow. Okay, now this attack flow at the same time will be available to rate teaming as well as it is also available to the threat hunting team. Now the intelligence team will actually convert that attack flow into D and TH hypothesis, detection engineering and threat hunting. Now, threat hunting team will do actual hunting. They will convert that, let's say, adversary XYZ, or let's say I want to identify resolver rat. Okay, now what are the techniques available for that? So, how many log sources I have? Now, after that, they will write the complex queries to detect that attack scenario. Now, once it has been completed, now they will take that back to upper layer, which is the top layer. It is the consolidated layer where every input that we have gathered right now, it will be as a you can say combined smaller set of output that will be passed to detection engineering team. Now, detection engineering team will run the exact scenario and everything, and they will say that, boss, this is something which is not possible. I have to put an engineering effort. I have to create an algorithm. If I want to identify randomized beacon, or if I want to identify tunnel, I want to identify fast flux DNS. Fast flux is the scenario where you will have one particular domain with the multiple IPs behind it. Okay, I want to have a DNS shadowing attack where you will have one particular main domain and you will have hundreds of subdomain coming in. So if I want to identify this sort of scenario, it is very difficult for you to detect. Okay, so what you will do? You will take that to engineering effort. Now, a detection engineering team will write the work with the programming engineering team, or let's say they will involve Python scripters or shell scripters or any other type of scripter. They will convert that into a detection. So if you want to build your own practice, okay, this is the one best flow that you can have. it this flow can be changed by every enterprise. This is the something that I built. Okay, it is the open available, and you can follow this. If you want to build your own, you can learn from this and you can build your own. So this is the general practice that one can follow. And then I will take leave. And this is I'm done from my side. So if anybody wants to connect with me, this is the blog site what I have, and this is the LinkedIn page. You just scan it and you can actually connect with me on my social media. Over to you, Ram.
Like I said yesterday when we were prepping for this, there's a lot of information that I'd like to deep dive into separately. And so there will be a Bahubali part two.
Sure. I will
So,
more than happy to talk more almost 2 hours in the only in lab because it was very
yep,
small session. So like,
yep. So, I mean, one of the things about good teachers is that once you ask them to say something, they'll go on non-stop and make sure that people understand and cover the entire syllabus that they sort of set out to, and whatever agenda that they set for themselves, and they'll do it on time. And I think it's suffice it to say that Rohit, you've been an amazing teacher this 1 hour, and I can't wait to have you back, to be honest.
I will be more than happy to.
Yeah, so thanks so much again. I posted the link to your Hack for Lab blog on the chat, and you showed it as well, and I'll include it in the description. I'll maybe include your LinkedIn on the YouTube description as well, so people can get to it. If folks have questions, feel free to reach out to Rohit directly through his social profiles. And once again, thank you so much, Rohit, for taking all the time to prep and taking the time to present here today.
Thanks, Ram. And we'll connect again for sure. Bahubali part two.
Yeah.
Yeah.
So, very quickly, just a couple of quick housekeeping announcements. We'll be back with another live stream this Thursday at 8 p.m. IST. And that's going to be, you remember how I said Open SSF at the beginning? A lot of people wonder what the Open SSF is and how it operates and things like that. And so I'm going to do a session for about an hour. Same kind of tone. I'm going to be joined by Manish, who's a DevSecOps engineer. And the idea is to introduce a lot of the Open SSF work to the community. Not a lot of people know what it is and what it stands for, and I'm going to take this as an opportunity to do that. So hopefully I'll see you on that stream. Thanks again, everybody, for tuning in today, and I hope that you tune into a future stream as well. Take care now. Bye bye.